Okay, so for whatever reason, my video got cut off. So I'm going to continue with what I was saying. So y equals 2x. So if I do 2 of these, which gives me 6, I'm going to have to add 4 to get 10. So the function rule would work for that one, but doesn't work for 4 and 12. So 2 times, y equals 2 times my 4 plus another 4. That gives me y equals 8 plus 4, so y, or my output, would equal 12. So this works for this one, and it worked for this one. Let's see if this same rule works for the others. So if I have my output of 8, that should equal 2 times my input of 2 plus another 4. So 8 equals 4 plus 4, so 8 equals 8. Well, it works for that one too. Let's try the next one using my 1 and my 6. So what I'm doing, in case I've lost you a little bit, is I'm using this same function rule, or the rule that I think it's going to be. I'm putting in my output of 6, putting in my input of 1. So 6 equals 2 plus 4, so 6 equals 6. So it works for that one as well. So this function rule is y equals 2x plus 4. So you are going to have some trial and errors on some of these. Look at example 2. So same thing, I have an input of x and an output of y. First thing I want to look at is if from x to y it gets bigger, I'm probably going to be multiplying. If it gets smaller, I'm probably going to be dividing. So from x to x, I have a 1 and a 1, so that doesn't really help me out a whole lot. But 2 to a 4, that is getting bigger. So again, it's probably going to be something times x. And again, I don't know if I'm adding or subtracting. Okay, so that's what we're kind of looking at. So I'm just going to start guessing. Well, 2 times 2 gives me 4. But if I do 3 times 2, that gives me 6. So it doesn't give me that. So just taking it times 2 is not going to work. 2 times 1, that's not going to be enough. So if I do 2 times 1, so 2 times my output, or my input rather, that gives me my y equals 4. So that's not going to do anything. So let's do 3 times this. So if I do 3 times 2, so 3 times my 2, and I need this to be a 4. So I'd have to subtract 2 to that. So y equals 6 minus 2. The output would equal 4. Okay, so that's what I have here. Let's see if it works for the next one. So let's go back and rewrite this of y equals 3 times my input minus 2. Let's see if that works for the next one. Of y equals, the 3 stays the same, times my input of 3 minus my 2. There's 9 minus 2 gives me a 7, an output of 7. Well, it worked for that one. Let's work for 2 of them. Let's try it with the 4 and the 10. So y equals 3x minus 2 is what I think the function rule is going to be. So y equals 3 times my 4 minus the 2 gives me 12 minus 2, which gives me 10. So it worked for that one as well. So let's do it for the last one. Y equals 3 times 1, which is 3, minus the 2, which is 1, and that works. So my function rule for this input-output is y equals 3x minus 2. Okay, let's jump to example 3. Again, it's getting larger, so from 5 to 7, it's getting larger, so I'm probably going to be multiplying. So if I take this times 2, so 5 times 2 gives me 10. So I'm thinking 2 times my x, that would give me 10. So 10 to give me to 7, I'd have to subtract 3. Let's see if that works. So y equals 2 times 5 minus my 3 gives me 10 minus 3, so y equals 7. So it works for that one. Let's try the next one. So 2 times my input of 9 minus the 3, y equals 18 minus 3, so y equals 15. Well, I have a 19 here, so this rule does not work. Okay, I'm going to grab another sheet of paper. Okay, so that last one we tried that didn't work is y equals 2 times my input. So let's try 3 times the input. So 3x, so y equals 3 times my 5. And I'm looking for an output of 7. So if I have 15, I'm going to have to subtract 8, which gives me y equals 15 minus 8. So y equals 7. So that works for that one. Go to the next one. So my input of 9, so y equals 3 times my 9. Subtract 8, because that's what I did up here. I get y equals 27 minus 8, so y equals 19. Well, that's what I'm looking for, so looking good so far. Let's try it for the 10 and the 22. So again, this is what I'm looking at for my rule. So y equals 3 times 10 minus 8. Y equals 30 minus 8. So y equals 22. So it works for that one. And 6 and 10. So y equals 3 times my 6 minus 8. Y equals 18 minus 8. So y equals 10. I have an output of 10. That's what I'm looking here. So this rule works for all 4. So my rule, oopsie, and I'm sorry I ran out of room down here. Let's try that again. So my rule for number 3 is y equals 3x minus 8. So 3 times my input minus 8 is going to give me the correct output. One more example. I want to make sure that I had one where it was not multiplying. So if I look at this one, notice remember I said up here that if we are going bigger from x to y, probably multiplying. Well, now I'm going smaller from x to y. So we're probably going to be dividing x by a number. Okay, so let's see. If I divide, I actually think that working with x's is, or excuse me, working with zeros is almost more difficult. So let's go with this one. If I divide, let's make it easy. If I divide this by 2, so my output has to be 1. So 1, my output, would have to equal half of my input. And if I put a 2 in here, I get a 1. So 1 equals 1/2 times my 2. Those are going to cancel, and I get 1 equals 1. So the y equals 1/2 x works for the 2 and the 1. So let's see if that same thing works here. So in other words, if I take half of my input, is that going to give me my output? So 4 divided by 2. Y equals 1/2 of 4. So y equals half of 4, which is 2. I'm looking for 0, so that's not going to work. I'm not going to use a 3 because 3 is not going to go in here evenly or here evenly. So third's not going to work. 4 is not going to work. I'm going to stick with the half and see if I can't find another way of doing it. So we have, if I take half of this, so I need my output to be 0. If I take half of my input, how am I going to get 0? This has to be a 4. So 0 equals half of 4. So half of 4 is going to give me 2. So in order to get a 0, I'd have to subtract 2. So y equals 1/2 x minus 2. So half of my input would be 2. Let's put this in here. So I'm looking at 4 and 0. So if I put a 0 in for my output and half of my input of 4, well, that gives me 2 minus 2. That does give me 0. See if it works for 6 and -1. If I put a 6 in here, that gives me 3. 3 minus 2 gives me a 1, but not a -1. So that's not going to work. Okay, I'm kind of running out of some options here, so I'm thinking, what would happen if I made the 1/2 negative? Let me get another sheet of paper out. Like I said, this is kind of a guessing game. So we're going to try what happens if I make the half negative. So my output, half of my input, so let's try the 6 and the -1. So my -1, putting in my 6, I got to figure out what's going to be happening here. So -1 equals, this is going to give me a -3. So if I add 2 to this, it's going to give me my -1. So I'm kind of guesstimating that my rule might be -1/2 x plus 2. Let's see if that works for my other ones. So 0 and 2. If my output is 0, if my output is 2, and I take half of my input of 0 and I add 2, well, what is 0 times anything? Gives you 0. I have 2 equals 2. Well, it works for that one. Let's see if this same rule works for 2 and 1. Move my paper up. So I have the output of 1 equals -1/2 times my input. I said adding 2. Those cancel. Gives me -1 plus 2. I get 1 equals 1. It works for that one. One more to try. Output of -1. -1/2 times my input of 6 plus my 2 gives me -1/2 times 6 gives me a -3 plus 2. -1 equals -1. It works for that. So that one took me a little bit longer. So I end up with y equals -1/2 x plus 2 as my function rule for that one. Whew, a lot of work.